We're going to take a look at these practice trig problems. And when we answer, because we're learning this in calculus, we're going to answer between 0 and 2 pi. So I'm skipping ahead. I skipped over some of the polar stuff to do together, but all right. So your goal is to get x by itself. So your goal is to get the trig function isolated on one side of the equation. So this first one is pretty easy. You would subtract 1 to the other side and then divide by 2. So where is the sine of x equal to negative 1/2? So I like to think of all students take calculus. So where is sine negative? Down here in these two quadrants. So I'm looking for two solutions, and they are going to be 30-degree reference angles because the sine of 30 is 1/2. So I need my pi over 6s. So in this quadrant, it would be 7 pi over 6. And in this quadrant, it would be 11 pi over 6. So you need to get to know your unit circle a little bit again. In number 2, we're going to add 2 to the other side and then take the square root. So we would have that the secant of x is equal to plus or minus the square root of 2. So we are actually looking for an angle in every single quadrant because secant is positive where cosine is positive and it's negative where cosine is negative. So all 4 quadrants are going to have a solution. And root 2 is partnered with the reciprocal of root 2 over 2. Cosine is root 2 over 2 at 45-degree reference angles. So secant will be root 2 at 45-degree reference angles. So you'd want to grab all of the pi over 4 reference angles. So those would be our 4 solutions for that. Let's see. So number 3 has a 3x on the inside. So that's going to affect our answer a little bit at the end, but we start the problem the same way. We're going to add 2 to the other side and then divide by 2. So that would give me that the cotangent squared of 3x is equal to positive 1. Now when I take the square root of both sides, I am going to get the cotangent of 3x is equal to either plus or minus 1, right? Positive 1 or negative 1, because you're squaring it over here, so you'd get positive 1 either way. All right, so we're going to set this aside for just a second. Where is the cotangent equal to positive or negative 1? So it's equal to that at all of the 45-degree reference angles. So my first step is I'm going to write down those 45-degree reference angles. 5 pi over 4 and 7 pi over 4. That's between 0 and 2 pi, but 3 x's are equal to those possible answers. I need to solve for just x. So when I go through, I'm really multiplying by 1/3 on each of these to get rid of the 3x over here. So what would I get over here? I would get pi over 12, because 3 times pi over 12 gives me back my pi over 4. I would get pi over 4. I would get 5 pi over 12 and 7 pi over 12. So I can actually go further than this because this took me to 2 pi. This no longer takes me all the way to 2 pi. So I can actually keep finding more angles. So I'm just going to go another revolution of pi around. So if I'm at 7 pi over 4, then I would be at 8 pi over 4. So I'd be at 9 pi over 4. I'm just going to keep going. 9 pi over 4 would come next. And then 11 pi over 4, 13 pi over 4. See how there's a pattern and I'm just adding 2 pi over 4 each time. 15 pi over 4, those would each get divided by 3. So there's actually a lot of answers to this problem. So let's see. If I did 9 pi over 12, what would that reduce to? 3 pi over 4, 11 pi over 12, 13 pi over 12. What does 15 pi over 12 reduce to? Divide by 3, 5 pi over 4. So I still didn't hit my 2 pi answer. So I could go probably one more round, right? 15. So I could have gone 17 pi over 4, 19 pi over 4, 21 pi over 4. I don't think on flipped math they would have you go this far, but this is good practice of your unit circle. So then you could divide each of those by 3. How are we going to know when to stop, though? Let's see. So I'd have 17 pi over 12, 19 pi over 12. I'm sure 21 pi over 12 reduces by 3, 23 pi over 12. Aha, I know that I've reached the end because if I'm at 23 pi over 12, what is 2 pi? 24 pi over 12. So I wouldn't be able to go past that. So sorry, there were a lot of answers to that, but that was a good way to look at when you have a multiple angle, how do you figure out what your actual answers are and how do you figure out how far you can go to get all your solutions? All right, number 4. I can't just divide something to the other side because I have multiple trig functions, so you want to think about factoring. So on number 2, do you see how you could factor out a cosine of x? So now you'll have 2 sine of x minus 1. Now you can use the zero product property. Where will this equal 0? And where will this equal 0? Cosine is easier. So cosine is 0 at either pi over 2 or 3 pi over 2, right? Because that's the top and bottom of the unit circle. This is asking you, where will the sine of x equal positive 1/2 if I set that equal to 0? Sine is positive in quadrants 1 and 2. So that would be at either pi over 6 or 5 pi over 6. So if you plug any of those solutions in, you'll get 0. All right, we're going to do these 2 last ones together, and then I'm going to have you pause and try the ones on the back page, and then I'll put the answers up. This is also a factoring problem. Let me rewrite this as something you might recognize. 2x squared plus 3x plus 1. That's an easily factorable quadratic, right? 2x plus 1, x plus 1. If I FOIL it, I would get back to that. So I really have 2 sine of x plus 1 times the sine of x plus 1 equals 0. So now I can set each of these with the zero product property equal to 0. So in this case, if I write this out, the sine of x would have to equal negative 1/2, or the sine of x would have to equal negative 1. I like to write my unit circle. Sine is negative down here. So let's see, we're at a half again, so that's a pi over 6 angle. So that would be 7 pi over 6 and 11 pi over 6. And where is sine negative 1? At this quadrantal angle, 3 pi over 2. So those would be your 3 solutions. All right, and then number 6, it looks like we'd have to take the square root of both sides. So where is tangent of x equal to plus or minus the square root of 1/3? We usually don't write it this way. The square root of 1 is just 1, and then we've got a root 3 in the bottom, and usually we rationalize this, so it's root 3 over 3, and that's a 30 reference angle. I think of tangent of 30 as having 2 3's, root 3 over 3. Tangent of 60 is just root 3. So I need plus or minus. So I need all of my quadrants, and it's a 30-degree reference angle again. So pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. So this will be good practice of remembering those special angles. So now we're not going to do this page today. We'll save that as more practice in class. But you've got these 6 problems on the back side. So pause the video for about 10 minutes, see if you can answer them yourself, and I'll be back to show you the answers. All right, let's work through those answers. We're going to find it between 0 and 2 pi, working in radian mode. So number 1, you should have recognized you could factor out the greatest common factor, and then you'd have sine of x as one of your 0 product property factors, and then 2 sine of x plus 1. So where is the sine of x equal to 0, and where is the sine of x equal to negative 1/2? Sine is 0. Let's see, this is strictly less than 2 pi. So we're going to say when x is 0 and when x is pi, sine is 0. I don't need to list 2 pi. And where is sine negative 1/2? Sine is negative down here. So that would be at 7 pi over 6 and 11 pi over 6, because that's 30-degree reference angles again. All right, number 2, let's see. Subtract the 3 to the other side. 2 tangent squared equals 6. Divide by 2. Tangent squared is equal to 3. Take the square root. Tangent of x is equal to plus or minus root 3. This is a 60-degree reference angle this time, and it's all of the 60-degree reference angles. So pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Let's see. Add 2 to the other side and divide by 2. Sine squared would equal 1. Take the square root. Sine of 3x is plus or minus 1. So 3x has to either equal pi over 2 or 3 pi over 2. Top and bottom of the unit circle. But then I'm going to divide these both by 3, which is like multiplying them times 1/3. So this would become pi over 6, and let's see, the 3's cancel, so I would just have pi over 2. But now I can actually keep going because I haven't gone all the way around 2 pi yet. So let's think. Pi over 2, now 3 pi over 2 on the bottom. So if I add another pi, I'd be at 5 pi over 2. If I add another pi, I'd be at 7 pi over 2, 9 pi over 2, and 11 pi over 2. 1, 3, 5, 7, 9, 11. See the pattern? Divide them each by 3. So this would be 5 pi over 6, 7 pi over 6. Let's see, this one would be 3. I'm dividing it by 3. So I'd have 9 pi over 6, divide them by 3. 3 pi over 2 and 11 pi over 6. And I know I'm almost at the end because 12 pi over 6 would have been the end of the unit circle, 2 pi. So all of those solutions. Did you get that one? I think that one was the most challenging one on this sheet. Where is sine of x equal to 1/2? So that's just these two quadrants, 30-degree reference angle, pi over 6 and 5 pi over 6. Maybe you're getting faster at these after this 11th and 12th problem here. This is another factoring one. It factors a little bit differently than the one on the front page because of that minus sign. So you'd have what, a minus here and a plus here to get the -2 sign or negative sine of x in the middle. Where is sine of x equal to -1/2, and where is the sine of x equal to +1? This one's easy, pi over 2. This one is the -30-degree angles. So 7 pi over 6 and 11 pi over 6. All right, where is tangent equal to 0? It's at some of our quadrantal angles, right? 1, 0, 0, 1, negative 1, 0, 0, negative 1. Sine divided by cosine has to equal 0. So I want my sine value to be 0 and my denominator to be 1 or negative 1. So it looks like at 0 and at pi and at 2 pi, but I don't need to list the 2 pi. So I hope that was a good trig review. We can talk about questions if you have questions.